Good morning. This is your stats sensei, Mr. Spensei, and I'm having a lot of technology problems, so hopefully this will go through this time. A consumer group compared the long, and this is the quiz, and I'm going to go through question one. This will be a fairly long video, so you may want to put it on an increased speed. So a consumer group compared the longevity of two types of razor blades in an expensive generic and a more expensive name brand. The consumer group was interested in testing the manufacturer's claim that the name brand uh, expensive blade remains sharper longer. That's important because this tells me they expect the name brand to last longer than the generic. 10 men, that's important, who have shaved regularly were randomly assigned. This is important because this tells me I'm working with an experiment. All right, to either the generic blade or the name brand. After the blade went dull, the men shaved with the other blade. The number of shaves obtained before the blade became too dull to provide a close shave was recorded for each blade in the table below. So essentially we have 10 men, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 20 readings. That means each man was tested twice. If each man is tested twice, or then we are dealing with a paired t-test. All right, I input this data right here, the generic into L1 and this into L2, and they sometimes will give you check figures so that make sure that you have it right. So there's my data in the calculator, and I go to stat calc, one var stats, and I go to L1, and then I have 107.1, and then my standard deviation is 14.05. So that means I've input that data correctly. Then I'm going to go back to stat calc, one var, and I'm going to second two, and I'm going to check, and I go, oh, there's 111.2, and here is my standard deviation. So it looks like I have both data sets in the calculator correctly. All right, what they ask us to do is determine at the 5% significance level whether or not the claim of the name brand manufacturer is accurate. Well, we could have done name brand is greater than generic or generic is less than name brand. This is what I did. Generic is less than name brand. All right. So here we go. First thing, we have to define our parameter. So let mu d equal the true population mean of the differences in blade longevity, generic minus name brand. You have to say which way you're subtracting. Now, if you subtracted the other way, that's fine. Your null and your alternative will be switched. So because it's paired, I'm going to say, well, that means there's no difference. All right. So the claim for a paired test is always no different. So HO, the mu D equals 0. The alternative is that it's negative because this is supposed to be less than that, which means I'd have negative. Again, if you flopped it, it would be greater than. Conditions. They started off with a random assignment of 10, and that was given. It's important that we say random assignment. If you say a simple random sample, that's wrong because it's an experiment. So because it's an experiment, we have to say random assignment. And they use the word assignment in their prompt. The differences are independent, and the blade longevity for one man should not be impacted by that of another. What that's saying is when you shave and I shave, my shaving shouldn't impact your shaving. The next condition is the n is less than 10%. Well, please remember the n is less than 10% condition is only used for observational studies. If we have random assignment, if we have an experiment, we do not use the n is less than 10% condition. If you used it on the quiz, we're not counting it wrong, but you need to leave that off of your test. Again, n is less than 10% condition, very necessary for surveys and observational studies, but we do not use it for experiments. All right. So then the next thing I need to check is normality. Well, to check normality, I need to do a box plot. Well, what that means is I'm going to have to find my actual differences. So I'm going to go to stat edit. I'm going to go to second one minus second two. That's generic minus name brand. And there's my differences. Now I'm going to go to second stat plot, turn that on, drop down, select the box plots. My X list is an L3. My frequency should be 1, and I should be able to press zoom 9, and get my graph. And we can use the trace feature and the arrow button to get the actual values, which is what I've done. And I see this distance and this distance. This distance and this distance are about the same. It's like, okay, it's not perfectly symmetric, but that's 50%, and that's the same 50%. All right. So, and we make sure we label it differences in the number of shaves, and it's generic minus name brand. The box plot is reasonably symmetric with no outliers and appears to be normal enough. All right, and appears normal enough. Now we're ready to actually run the test. And I start off by writing my formula. So T equals X minus mu S divided by square root of N, because it's a one sample, but I need to drop some D's on it because we're working for the mean of the differences. And so this means I'm running a paired t-test, and I should label this, and I don't have a whole lot of room. So paired t-test labeled right there. Again, it's centered on 0 because that's my claim right over here. I'm going to go ahead and run my test at this point. Stat, arrow over to test. There it is, t-test, and press enter. I have data highlighted because I inputted data into L1 and L2. My data list that I care about is in L3, so second followed by 3. And I have the less than symbol because that's what my alternative indicates. And I'm going to calculate. So now I have my X bar. So the probability of T is my X bar D is going to be negative 4.1, minus my mean. Well, the mean was the claim of 0. My standard deviation is 12.827, and the sample size was 10. And that gives me the probability that T is less than, we always have to have that, negative 1.0107. All right. So I want to go back up and add a couple things to my graph. First off, we know X bar now. We know that this is negative 4.1. All right. And that's what we were testing. We also know a couple other things. We know the T statistic is centered at 0. So there's my T statistic centered at 0. And we know that the T value is negative 1.0107. And we know that this shaded area is now 0.1692. All right. So the probability that T is less than this gives me a P value of 0.1692. And alpha, they gave us is 0.05. This is less than, excuse me, this is greater than 0.1692 is greater than 0.05. So in this case, we're going to fail to reject HO. All right. So now we need to do our conclusion. And our conclusion is simply this. Our p-value is 0.1692 that we brought down from above. We failed to reject a null. There is not sufficient evidence at alpha equal 0.05 to suggest that the generic brand blade shaves fewer times than the name brand. And then we need to answer the question. And the question that they said is, should they make the claim? And our test does not reject a null, and the manufacturer should not claim their blade lasts longer than the generic. All right. So we need to make sure that we also include that as well. That's the final statement on that. The next part, it says create and interpret a 95% interval for this for the above scenario. So once again, I need to come back and I need to write my formula. But in this case, we're working with paired, and so so this is a one sample T for paired data. right? And I need to start plugging into my formula. And by the way, it helps that we've already done the, since we've already, on part one, we've already defined the parameter, we've already written all the conditions, we don't have to do it again. So we've already done that part. So I'm going to go back over here and I'm going to go, well, let's run the test, stat test, and we're going to drop down to T interval. And we're still working with data. Our list is an L3 and it wants us to run a 95% confidence level, so 0.95. And there's my interval, but I need to plug in my data. Well, X bar is negative 4.1. Plus or minus, we're going to leave T star for a moment. And we need 12.827 as our standard deviation divided by the square root of our sample size of 10. So I'm going to go ahead and write down my interval because I'm going to need that in a moment. And my interval is negative 13.28 and 5.0762. So then I come back and I go, all right, how do I get T star? Well, I'll go to second vars, inverse T. My area is going to be parenthesis 1 minus 0.95, close parenthesis, divided by 2. And my degrees of freedom is going to be 10 minus 1. Because we had 10 pairs of data. So my T star is 2.2621. If I draw my graph, my graph is centered at negative 4.1. And then we have 0.95. And my lower bound is negative 13.28. And my upper bound is 5.0762. And then for the T values, the T is centered on 0 always. And we have 2.26 and we have negative 2.26. Okay, so that's my graph. And we found this is my lower bound. This is my upper bound. So what are we? Well, we are 95% confident that the true population mean of the difference in blade longevity, generic minus name brand, and all we did is restate what we have on the front page, lies within the interval, in this case, negative 13.78 to 5.0762. And in repeated sampling, this method, and we expect this method to capture the true population mean of the differences in blade longevity 95% of the time. Great. And then the last part was the name brand manufacturer claims that their razor blade may provide an average of 10 or more close shaves above what the generic brand is able to provide. Is this claim plausible? They're not saying is it proved, is it plausible? The name brand's claim is plausible because negative 10 lies within the interval, indicating the generic brand might last 10 shaves less than the name brand. So we didn't prove it, but it's a plausible response. In fact, negative 13.7 shaves longer is possible. Or maybe the generic brand lasts 5 shaves longer. So this would say the name brand lasts 13 shaves longer. This says the generic lasts 5 shaves longer. And based on the confidence interval, we can't say that there's a difference, but we can say it's plausible that the name brand might last 10 shaves longer. All right, please remember, any value in between there is a plausible value. Thank you for watching.